Next one is bond energy. It is denoted in the symbol E. In chemistry, bond energy is also called as mean bond enthalpy or average bond enthalpy or bond dissociation energy. These are all same. Bond enthalpy, bond dissociation energy, bond energy, all are same. It defines the amount of energy required to break apart a mole of molecule into its component atoms. Or one more definition I will give. It is the energy required to break 1 mole of covalent bonds present in the gaseous state substance. So, bond energy is the energy required to break 1 mole of covalent bonds present in the gaseous state substance. So, the example is here in Cl2 molecule, it having a 1 mole molecule, 1 mole covalent bond. The bond energy required to break this bond is 242 kilojoule per mole energy. At this energy, we are going to break this Cl-Cl bond. This bond is called as a covalent bond. So, this is about bond energy. Next one is factors affecting the bond enthalpy or bond energy. First one is atomic size, electronegativity, and then bond length. Coming to the factors affecting that, first one is atomic size. In this, atomic size is inversely proportional to bond energy. That means lesser the atomic size, more is the bond energy. But greater the atomic size, lesser will be the bond energy. In the case of fluorine, chlorine, bromine, iodine, look here, fluorine having a small size when compared to chlorine, when compared to bromine, and compared to iodine. So in this iodide, it having a more size. More size means it decreases bond energy. The fluorine having a less size, it increases bond energy. So look here, in the case of hydrogen fluoride, is greater the bond energy when compared to hydrogen iodide. So smaller the size, more will be the bond energy, higher will be the atomic size, less will be the bond energy. And next one is electronegativity. So in the case of electronegativity is directly proportional to bond energy. Greater the electronegativity, greater will be the bond energy. In these two cases, this is the best example. Look here, fluoride molecule having a most electronegativity when compared to iodide. So it having a more bond energy when compared to iodide. Okay. In the case of more will be the electronegativity atom, more will be the bond energy. Here greater the size, lesser will be the bond energy, but lesser will be the atomic size, greater will be the bond energy. And the third point is bond length. In the case of bond length is inversely proportional to bond energy. Here also, if the bond length is more, it requires more bond energy to break this triple bond. But the bond length is more, lesser will be the bond energy is required to break this bond. This is all about factors affecting the bond length. And next one is significance of bond energy. The bond energy increases as the bond order of the molecule increases. Understand? Bond energy increases, bond order of the molecule increases. Look here, if bond order is 3, 3 means triple bond, right? So when we have to break this triple bond means we have to require more energy. In the case of bond order 3, bond length is small. Understand? But if bond order is 1, 1 means single bond. Less energy is required to break this single bond. In this case, bond length is large. Bond length is large. This is the first significance. And second one, as bond length decreases, the bond strength and stability also increases. and hence bond energy also increases. Right now, here in the case of triple bond molecule, bond length is small. In this case, bond strength and stability is also more. So bond strength and stability more means it requires more energy. In the case of single bond, bond length is large, but these single bonds are least stable and least strength. Bond strength is least in the case of single bond. In the case of triple bond, bond strength is more. This is the second significance. What is, if the bond length is decreases, the bond strength and stability also increases, and hence bond energy also increases. And third one is, as bond energy of the salt increases, the solubility of the salt in the solvent decreases. Bond energy of the salt increases. That means in the case of NaCl, it contains less bond energy when compared to magnesium oxide, MgO2. It having a more bond energy. This means bond energy of salt increases. In this case, the bond energy of the salt increases, but it is less soluble in the solvent when compared to NaCl. So NaCl is more soluble in the solvent because its bond energy is less when compared to magnesium oxide. This is all about bond energy or bond dissociation energy or bond enthalpy. All three are same. And that tomorrow I'm going to explain this polarization. Sorry, it is finished now. Next class I'm going to explain polar and non-polar molecules and dipole moment. Thank you.